Why is it stapled so they stay together when I hand them to you guys? All right, I'm starting whether or not you guys are ready or not. So from these notes, we're going to focus on writing the equation of a tangent line. So the whole idea of this whole unit 4, is you guys are learning about possible applications of the derivative. So in the real world. So you guys have talked about related rates so far. You guys have talked about position, velocity, acceleration. You guys have talked about like speed, when something's increasing or decreasing. We've talked about when something's at rest. And then we did a couple of those AP exam practice problems. You guys know what I'm talking about with the penguins and stuff like that. So what we're going to be doing now is, what if we have a ugly point that we want to know what the tangent line or the derivative of that is? We can use a tangent line to help us figure it out. So the whole idea of this is, you may or may not be allowed a calculator on something like this, but if we don't have a calculator, we can get really close to what the actual value is. So we're going to be able to highlight this, use tangent lines to approximate a function value near the point of tangency. And we'll talk about what that means. So recall that a tangent line is just a line. To write the equation of a line, we need a point. What's wrong with my pencil? We need the point, and we need the slope. So let f of x be a function. To write an equation of a line tangent to f of x at some point x equals c, we must know two things. Number one, we need to know what c is, and then we need to know what the function is when you plug it in. So to do this, you just plug in x equals c into the function. To find the point on the tangent line. You guys have already done this already. To find the slope, makes sense, plug in the derivative, plug in the value into the derivative. So plug in x equals c into your derivative to find the slope. Does that sound foreign at all? That should sound familiar, right? This should be easy. It's just, I'm just showing you guys what you can do with the tangent line. And it's not in these notes, but what's cool about these notes is you can actually do this. Like, for example, guys, what's the square root of 36? 6, right? We can use calculus to figure out without a calculator what's the square root of 38. And I'll show you guys how to do that later, but it's really cool. Because what's cool is you can do it by hand, and then you check it on your calculator, and it's almost exact, and it's really cool. It's like, I don't know, I'm really nerdy, so I get like goosebumps. I get math goosebumps, because that's like really cool that that's true. All right, point slope form. What's point slope form? Y minus y1 is equal to m times x minus x1. Or, using more fancy calculus notation, we could say, in this case, y minus f of c is equal to f prime of c times x minus c. This is just another way to write it. If you guys know this still, you're fine. All right, so let's do an easy one first, and then we'll kind of dive into some harder stuff. So let f of x be equal to 3e to the 2x plus 5. Write an equation of the tangent of the line tangent to f of x at x equals 0. So whenever we have to do this, my recommendation always is first to write y minus y1 is equal to m times x minus x1, because then you know what you need and what you need to find. So you guys with me that we know x equals 0? Okay. Does that make sense that this would be your x1? right? Do we know y1? No. To find it, what could I plug in? 0. So y1 is going to be equal to f of 0. So if I plug in 0 into my f, I'm going to get 3e. Can you guys see that, or is it too small? You guys can see it? Okay. Don't be shy. You guys good? Okay. 2 times 0, and then plus 5. Okay. Stay with me, guys. 2 times 0 is 0. Anything to the 0 is what? 1. So this is just 3 times 1 plus 5. That's just 8. Now to find the slope, I need to take the derivative. So I need to take the derivative of my function. Okay? I need to be careful though, because it's 3e to the 2x, so I need to use the chain rule. So the derivative, so f prime of x is going to be, well, this plus 5, what's the derivative of 5? Just 0, right? So I don't care. So the derivative, I'm going to say this over and over again, the derivative of e to anything is just e to the thing. So it's 3 e to the thing times the derivative of the power. What's the derivative of 2x? Just 2. Cool. Now, simplifying it, 3 times 2 is 6. So f prime of x is equal to 6e to the 2x. So to find the slope, I need to plug in my x value. So now I'm going to plug in 0 into my derivative. So m is equal to f prime of 0, which is going to be 6e to the 2 times 0. Again, this is just 0, right? E to 0 is 1. 1 times 6 is 6. Okay. Are we good? So write our tangent line. Y minus, what's y1? Is equal to my slope. What's my slope? Times x minus 0. If you guys left your answer like that on the AP exam, awesome. If you guys want to get fancy, you guys could rewrite it, but just to save us time, I'm okay if you guys leave it like that. It's almost better to leave it without, if you keep going and try to make it look pretty, sometimes like on an FRQ, if you make a mistake, then you lose points, okay? And we'll talk about that when we get there, like especially in the spring. When you guys do integration, I'll tell you guys, like, you guys can leave your answer unsimplified, and I'll give you credit for it, because I don't want you guys to make a mistake. I'm not testing your arithmetic, I'm testing your calculus, okay? Questions on this?
Yeah, so the following as y minus fc equals by f derivative. Am I disabled to write as that treat as y minus f 0 equals f derivative 0, the parentheses x minus 0?
This is the exact same thing, it's just another way to write it. Because what's our c in this case? C is 0.
Yeah.
What was f of 0? 8. It's just the same way of writing it. Oh no, it's just another way to write it. All right, example 2. The derivative of the function y is equal to k of t is given by dy dt is equal to 1/4 times y plus 5. It is known that k of 3 is 19. Write an equation of the line tangent to k when t equals 3. Okay. So in the AP exam, they're going to try to trick you. This is not the original function. This already is the derivative. So do you guys see how they give us the point 3 comma 19? Does it make sense that this would be your x and this would be your y? Okay. So now if I want to write my tangent line, I always am going to recommend writing this first. Do you guys agree we know x1? and we know y1. The only thing we don't have is the slope. So in general, to find the slope, guys, don't we plug in our value into the derivative? And look, they gave us the derivative. So you don't have to take the derivative again, because that's what will happen on the AP exams. Some kids will take the derivative of this because they're just used to doing that. They gave us the derivative. They're doing the hard part for us. So all I have to do is plug in what number? 3, good. So the slope is gonna be equal to my derivative. Hi. Thank you. Are you on? You're good. Do we understand what this means? Okay. The derivative when x equals 3. So that's how you show your work for that. So it's going to be 1/4 times, I'm plugging in, JK. I'm going to plug in 19. What's 19 plus 5? 24? 1/4 of 24? Which is 6. Okay, so my tangent line is going to be y minus 19 is equal to my slope times x minus 3. Now I'll remind you guys when we get closer to start doing like review, but if this was multiple choice, this may not be a multiple choice option. What they'll do sometimes is they'll rewrite this into slope intercept form, or they'll try to trick you. So if this doesn't look like let's say all your answers look like y equals 6x plus 12. What you would do is you would distribute, combine like terms, and then move that over, okay? And then find the answer that makes sense. I know it's not 6x plus 12, guys. I'm just saying. Okay. Questions on 2. Okay. So why are we doing tangent lines? So a tangent line, remember, is a line that goes through a point and it looks like it basically just crosses the graph right there and that's it. It gets really close. So if I want to know how to approximate a value, this is why we're doing it if it's not easy to evaluate. So notice the function f of x and then the tangent line t of x to the right. When x equals 5, the tangent line of t of x is the same y value as f of x. So that means that the values near x equals 5, the tangent line is near, I'll use a different color. The tangent line is near the graph of f of x. So this allows us to approximate f of x near x equals 5. So therefore, if I want to know if I know what f of 5 is, does it make sense that 5.1 is really close to 5? So if I know what the tangent line is at 5, then I could use the tangent line to figure out what's about 5.1, okay? So that's what I was telling you guys, like we know the square root of 36 is 6. Do you guys know what the square root of 38 is off the top of your head? No, but if you knew the equation of the tangent line, you could use that to figure it out. And it'd be pretty darn close. Okay. More tables. Okay, this is a really good question. So take that for what it's worth when I say that. What does that probably mean? It's probably going to be something like this on your tests. Because this shows me, do you guys understand derivatives? Do you guys understand how to read a table? Okay. The functions f and g are differentiable with selected values of f, g, f prime, and g prime given above. Let h of x equal f of g of x. Write an equation of the line tangent to h of x at x equals 4. So again, y minus y1 is equal to m times x minus x1. So, what's x1? 4? Okay. Do I know what y1 is? So the first thing we should do is plug in 4 into h to find y1. So stay with me. H of 4 is equal to, I'm plugging in a 4 in for x. So this is going to be f of g of 4. Now this is a composition. So remember we do like the inside and then do out. So with the first thing you're going to do is what is g of 4? So look at your table, guys. What's g of 4? 5. So this is the same thing as just f of 5. Now let me give you guys a hint. Whenever you guys are doing these, do you guys see how we got f of 5? Let's say you guys got 2. Do we have f of 2 or anything of 2 in our table? No, so I wouldn't give you guys something like that. It would, whatever you get here, it has to be in your table. Otherwise, it doesn't make sense. Okay? So what's f of 5 according to our table? -9. So this is your y1. So we know x1, we know y1. We need to find the slope. So to find the slope, what do I need to do to my function? Take the derivative. Now, this is a composition, right? We have an inside function, outside function, which means which rule do we have to use? Chain rule. Good. So h prime of x is equal to the derivative of the outside at the inside. And how does it finish? Times what? Derivative of the inside. Okay. So then h prime of 4 is going to be f prime of g of 4 times g prime of 4. So if I go to my table, if I look here, I need to do the inside first. What was g of 4 from over here? 5. So it's going to be f prime of 5 times, what is g prime of 4? -2. Okay. F prime of 5 is 3. So this is going to be 3 times -2, and that's just -6. Okay. Can you guys see how that would be confusing though? But is it impossible? Like the problems you guys had on your test, the one I graded on Monday, finally, while I had Stranger Things on in the background, because I'm trying to rewatch all of it before the new season comes out. There's a problem on your test where you guys had to do a product rule and a quotient rule from the table. I feel like those are harder than this, okay? Because you have to really be careful when you guys do the derivatives. All right, so write your tangent line. Y minus, what was y1? -9. So careful, y minus -9 becomes y plus 9 is equal to our slope, -6, times x minus 4. Okay, here's the thing that's different about these. You're going to use this to approximate, in the next part, h of 4.1. So what I'm going to do is, I want to get y by itself when I do that, so I'm just going to do that here. So y equals, the only thing I'm going to do is I'm going to take this and move it to the other side. I'm going to leave this exactly the way it is, and you guys will see why here in a second. So negative 6 times x minus 4 minus 9. So this is the equation I'm going to use. Okay, so use the tangent line from part A to approximate h of 4.1. So now what you're going to do is take your tangent line and you're going to plug in the value in for x. Cool. So y equals negative 6 times 4.1 minus 4 minus 9. 4.1 minus 4 is 0.1. Negative 6 times 0.1 is negative 0.6. This is negative 9.6. The entire test you guys take on Tuesday will be calculated. Just don't go, please, from here to here without writing anything down, please. Because if this is wrong, I can't give you any credit. Do you guys understand what I'm saying? If you guys write this but then make a calculator mistake, I at least know you know what you're doing. You just made a boo-boo when you typed it in. Okay, questions on what we just did? Do we understand what this means? Like why we just did that? No one's saying anything, so that doesn't make me feel good. Yes? Because this number is, you guys agree this number is really close to 4? So that just gives us, like, if I had a graph for this mess, this tells me on the graph, because these points are so close, I know the tangent line at 4, so I can use that to help me guess what 4.1 would be. Okay? All right. Another one. Let y equal f of x be a function where dy dx is equal to 3x over y plus 4 squared, containing the point 1 comma negative 5. Write an equation of the line tangent to the graph of y equals f of x at x equals 1, and then use it to approximate f of 0.8. Okay, again, what do they give us here? The derivative. So do I have to take the derivative again? No, please don't do that. So here's the derivative. They give us a point. So this is x1, this is y1. So to write my tangent line, what's the only piece of information I don't have right now? Slope. So to find the slope, I need to plug in, careful, I know x1 and y1. Do you guys see how there's an x and a y in our derivative? That means that whatever the function was, guys, they had to use implicit differentiation. That's what that means. Okay, that's why they gave it to us, because sometimes it's too much work to find it. Julian, you good? Okay. Plug in x and y into your derivative. So m is going to be the derivative at the point 1 comma negative 5. So I'm going to plug in 1 for x, so 3 times 1, divided by negative 5 plus 4 squared. That's 3 over negative 1 squared. So it's just 3. So my tangent line is going to be y minus, what's y1? So y plus 5 is equal to my slope times x minus 1. Now, like I told you guys, for the next step, it's easier if you already have y by itself. So I'm just going to kick the 5 to the other side. That means y is equal to 3 times x minus 1 minus 5. Okay, everybody okay? So now what am I going to do? Plug in what number? 0.8. So I'm going to use this to plug in right there. So then at x equals 0.8, y is equal to 3 times 0.8 minus 1 minus 5. If you guys wrote this and then wrote your answer, I'm cool with that. Okay, but I'm going to show more work just because I'm your teacher. Negative 5.6. Questions? Is this hard? No?
I believe my answer is y equals 3, 0.8 minus 1 minus 5.
On an FRQ, yes.
Oh, okay.
If it's multiple choice, it's probably going to be like negative 5.6, negative 4.6, 5.6, 2.
What about for the test?
For the tests, because you have a calculator, if you have a calculator, guys, please simplify. You'd leave it unsimplified like that if you have no calculator. Does that make sense? But majority of your AP exam is no calculator. You guys be fine. All right. On Thanksgiving. Hey, how convenient. We got 2 weeks. Isn't that crazy? On Thanksgiving, a delicious pumpkin pie was removed from an oven that has a temperature of 175 degrees. The temperature of the pie at time t minutes can be modeled by this function, where dp dt is equal to negative 1 over 50 times p minus 25. Use a tangent line to p at t equals 0 to approximate the temperature of the pie 4 minutes after being removed from the oven. Okay, so this one's tricky. Again, what do they give us? This is the what? Derivative, okay? So to find the slope, does it make sense I would plug in something in, right? So because, do you guys see how it's dp dt? That means my function really is p of t. Like if I take the derivative of p with respect to time, it would be dp dt. Does that make sense? So do you guys see how we only know t equals 0? How do I know what the y value is? So if we read the question, this means like 0 minutes after it's been removed from the oven. Do we know the temperature when it was removed from the oven? What? It tells us that when the pie gets taken out of the oven, it's 175 degrees. So I'm going to use the point p of 0 is equal to 175. So this is going to be like your x1 and your y1. That's the only thing that's different. It's just deciphering that. Everything else is the same. So to find the slope, do you guys agree, plug into your derivative? Okay, so careful. What number am I going to plug in? 0 or 175? Who thinks 0? Good, it's 175. Because this represents the temperature. So it's going to be negative 1 over 50 times 175 minus 25. So negative 1 over 50 times 150. 150 divided by 50 is 3. So this is just negative 3. So what's my tangent line? Y minus 175 is equal to my slope, negative 3, times x minus 0. To make my life easier, can I move this to the other side? So y equals negative 3. I'm going to call it x because x minus 0 doesn't matter. Plus 175. Okay. Are we okay? Now, What am I trying to figure out? Temperature at 4 minutes, right? So dp dt. Actually, no, JK. So P of 4 is approximately negative 3 times 4 plus 175, which is 163. If this is a word problem, we want to put it in the correct units. So what's the units?
Fahrenheit per minute.
No. Is it changing?
Oh no.
So it'd be
Fahrenheit.
degrees Fahrenheit. Good.